Okay, 1.4. The objective is to find the length of segments and find the measures of angles. So let's jump in with our vocabulary and our key concepts. Looks like we've got a couple more postulates to learn today. The first one is the ruler postulate. The ruler postulate says the points of a line can be put into one-to-one correspondence with the real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. So think about a ruler. It's measured off, and then it's labeled with numbers. So if I wanted to find the distance from the 4 to the 8, I could take 8 minus 4, and I know that that's 4 units away. That's what the ruler postulate says. Okay, next postulate is the segment addition postulate. It says if 3 points A, B, and C are collinear, that means they're all on the same line. They make a straight line, just like over here. And B is between A and C, so B's in the middle here. Then segment AB plus segment BC, you can add them together to get the whole segment AC. Okay, I know that seems kind of obvious, but sometimes you know what this AC or BC is, and you have an equation for AB, and then you can solve to figure out what all pieces are. So that's going to become very important here. The protractor postulate. Let ray OA be opposite rays in a plane. OA and OB, be opposite rays in a plane. So we've got OA and OB down here. OA, OB, and all the rays with their endpoint O can be drawn on one side of line AB. So just like a protractor, if we start at O, we can draw lines out in any direction to make an angle. Okay, on one side of line AB can be paired with the real numbers from 0 to 180, so that ray OA is paired with 0. Okay, if you look, OA, here's the number 0, that's how many degrees that is. And ray OB is paired with 180 degrees. Okay, it's just showing you angle measures. Okay, it also says if ray OC is paired with X, so that's this one here, and they labeled it X, and ray OD is paired with Y, so this ray, they labeled it Y, then we can find the measure of angle COD by taking X, the degree marker for X, minus Y, and finding the absolute value of that. So we would take whatever this degree is over here minus whatever degree is over there, and we'd be able to find the measure of that angle. It's kind of like finding the distance between 2 points. We're just finding the distance between the 2 rays in degrees. Okay, angle addition postulate. If point B is the interior of AOC, so as it looks like down here, we've got angle AOC right here, and point B is between them. Then the measure of angle AOB, so from here to here, this angle, plus the measure of angle BOC, so that's this angle down here. If you add those together, you get the measure of the whole angle AOC. It says if AOC is a straight angle, then AOB plus BOC, so like here, AOB plus BOC, it's a straight angle, it adds up to 180 degrees. Okay. A lot of new postulates, but all things that kind of We knew were true, we just didn't know why. Now we have a better understanding of why. All right, we've got some more vocabulary words. A coordinate, we're going to call this a location. It's always going to have like an X, Y, if that helps you remember. Okay. The length of AB. So we're trying to find the length of that segment over there. All we're going to do is take A minus B and find the absolute value of that. Okay. Congruent segments are the same length. So in our picture it shows AB is 2 centimeters, CD is also 2 centimeters. If they're both marked with these 2 little dashes, that means those are congruent. So that means AB is equal to CD, and that means AB is congruent to CD. This sign here is the symbol for congruent, okay? Equal means they're the same length, congruent means, or this sign means they're the congruent. Okay, midpoint is a point that divides a segment into 2 congruent segments. So, if we look at our little picture here, we've got the tick mark here on AB and right here on BC. That means that those are the same. That means B is the midpoint. So we know that both sides have to be congruent. Both segments are congruent. We split the line exactly in half. Okay, an angle, this is the symbol for angle right here, this little kind of sideways V, is formed by 2 rays with the same endpoint. We're also going to make a note that the rays are the sides of the angle. So if you look off to the side there, they've got a little example for you. Okay, we've got ray BT, ray BQ, and they make angle TBQ. Notice the corner of the angle, so like B is always in the middle when you write it with 3 letters. Alright, let's talk about different types of angles. First one we're going to talk about is acute. Acute has to be greater than 0 degrees, so it has to be an angle, but it has to be less than 90 degrees. Okay. Then we have a right angle, and it's exactly 90 degrees. Then if it's more than 90, we've got an obtuse angle. So 90 is less than x is less than, obtuse can't be more than 180 degrees. And last, we've got a straight angle, and that is exactly 180 degrees. Okay, so now we're going to write these out in words. We've got our examples. We're going to write these in words. An acute angle has a measure less than 90 degrees. A right angle has a measure of exactly 90 degrees. An obtuse angle has a measure more than 90 degrees. But less than 180 degrees. Remember, if I'm going too fast, go ahead, pause the video, write down what you need to, then keep playing it when you're done. Okay, a straight angle has a measure of exactly 180 degrees. All right, and then here's one that we haven't talked about yet. Congruent angles are exactly the same measure. So if we have two congruent angles and we know one of them 70, that means the other one also has to be 70.